Alright, this is Unit 11, Direct Current Circuits, Subunit Complex Resistor Combinations. In this video, I will calculate the current and potential difference across individual elements within a complex circuit. So, in this complex circuit you see here, we need to find the current and potential difference across the resistor 3 and resistor 6, here and here. So, to do this, we have to simplify the circuit, the schematic diagram. And so we start with this part of the schematic here. We can combine R3 and R4 because the resistors are in series. Therefore, their equivalent resistance is the sum of the two resistances. So R3, this new resistor here, which you can call R34, has a resistance of 9 ohms. And we can continue to further simplify this part of the schematic diagram because resistors in parallel can be combined with the equation here, with this equation. You take the resistance of the two resistors, the inverse resistance of the two resistors, add them together, and that will give you the resistance. So we have, well, it will give you the inverse of the resistance of the new resistor, which equals 2.25. So 1 over 9 plus 1 over 3 equals 1 over the new resistance, which equals 2.25. So now that we have this, we've gone from this schematic diagram to this schematic diagram. We can find the equivalent resistance of the entire series, and that is 14.25 ohms. So now that we have that, we can start to figure out the current and potential difference in resistor 6 and resistor 3. So to find the current, we use this equation here. Potential difference equals current times resistance. We have 12 volts equals current times 14.25 ohms, and that gives us 0.84 amperes for resistance. And because these resistors are in series, we know that resistor 6 will have this current, as will every resistor in this series here. So now that we know that the current in resistor 6 is 0.84 amperes, we can find the voltage using the same equation, and we get 5.04 volts in resistor 6. So now that we have resistor 6, we're going to move on to resistor number 3 here. And we know that the equivalent resistance of these all these is 14.25, and we know that the equivalent that the voltage for all these resistors is 12 volts. So we take the resistance of these three resistors, R1, R2, and R6, and subtract it from 12, and that gives us 1.9 volts. That means that this 1.9 volts is the potential difference in this resistor here. This resistor here is, in fact, this resistor here. So we use the 1.9 volts to find the current in R5. The current in R5, which will equal 1.9 volts, divided by 3 ohms. And that gives us 0.63 amperes. We know that there is 0.84 amperes going into this these resistors here, this series. So if there's 0.63 amperes here, it means that there's 0.21 amperes going through the resistor 3. So now that we know that resistor 3 has 0.21 amperes, we need to find the potential difference in resistor 3. Using this equation, we find that the potential difference is 0.84 volts. You see right there. So that was Unit 11, Complex Resistor Combinations 2.